Hey, I'm Ari Zitin. I'm an analytical training consultant here at SAS, and today we'll be talking about how to deploy models using SAS. So the idea behind deploying models is that you want to take your model that you've built, you've spent time and effort, you're working on it, you're making sure you have a good model that has good model performance, and you want to actually use it to score new data. And of course, for your business process, this could be something like scoring customers on whether they're likely to respond to a direct mail solicitation, scoring customers on whether or not they're likely to default on a loan, or even scoring transactions on whether or not these transactions are going to be fraud. In all cases, you need to take the model that you've developed and move it somewhere to wherever the data lives so that you can use that data and the model and create a score that you're going to use for your business process. Today, we'll be using Model Manager and Model Studio in SAS Via we'll use Model Studio to build our models, and we'll use Model Manager to deploy our models. And part of that deployment process is making sure that we know who's done what with the model, when they did it, how they did it, so that in 3 months or 5 months, you can check to see how your model's doing. You can evaluate whether you need to update it, whether you need to retrain it, or whether you need to build a new model. All of these sort of model manager tasks that we have are really part of deployment, because when you deploy the model and score new data, you want to make sure that what you're doing is the right thing, is achieving the business goal that you were originally intending when you built the model, and that the time between when you built the model and when you deployed the model, things haven't fundamentally changed. So it sort of gives you a repeatable process for taking a model from development all the way to usage in a way that you can record and know what's going on. So you can come back later and refine your work. So let's get started in Model Studio, build some models real quick, and then we'll bring the models into Model Manager to deploy them. So I'll select the top left, build models. Oops, something was already open. I'm just going to exit the already open project. I'll create a new project. I'll just name it, Model Management Example. I'll use a blank template. So this is some stuff we might have seen from other videos about using Model Studio. Right now, we're just going to build some models, and I'll tell you when we get to the model deployment phase. I'm loading up the data. We'll use this HMEQ dataset. You'll have access to this dataset on your own. Like all predictive modeling tasks, we need to start by assigning a target. In this case, we'll assign the target BAD, which is binary applicant default. So we're trying to evaluate whether or not customers from our bank are going to default on their loan. So we're going to use a bunch of historical information, like the credit card number or the age of the line of credit, in order to try and predict whether or not our customers are going to default on the loan. I'll go to Pipelines to build a simple predictive model. I'll just add a child node. We'll add an imputation node so we can impute missing values in the data. Under the imputation node, I'll add a supervised learning gradient boosting model. And I'll go ahead and just run the pipeline. We'll use all the default settings here since our focus is on taking this gradient boosting model and actually deploying it. Now that the pipeline's finished running, we could go to the model comparison node to look at the results of the gradient boosting model. But since it's our only model, we'll just go ahead and go to pipeline comparison. If I click up in pipeline comparison, I only have one model, so this was selected as the best model. We can see some error plots, and if we scroll down, we get some score output as well as ROC and lift. I always just like to look to make sure that our model did at least okay. So I'll look at the fit statistics. The easiest one, I always look at misclassification. We see we do about 10% misclassification, so our model's doing pretty well. From this pipeline comparison tab, we can bring our model into Model Manager. So I'll click this Project Pipeline menu and select Register Models. Ultimately, I want to manage the model, but it needs to be registered into Model Manager. Later on, we'll look at publishing models. So this registration is basically taking all of the metadata about the model and sending it over in a package to another application, Model Manager, that we'll be using shortly. So now that our model's registered, we can bring it into Model Manager. We could just access it straight from the interface menu on the left, but we have a shortcut here to manage this model. When I click Manage Models, it'll take me to a new interface where we can control who has access to our model. We can set commands for updating the model regularly. We can look at what sort of metadata the model expects. The first thing we see here when we get into Model Manager is a list of files. These files are all associated with the model. So if I look at DMCAS EP score code, for example, this is data step using the SAS data step score code for this model. So if you executed this on a new data set, you would essentially score the data set according to the model that we've generated. We also have this incomprehensible file, _1, ni, etc., etc. This is the A-store file, which is basically a binary file that you can use to score the model from a code call from anywhere where SAS will run as well. So there's different ways to package the model, and we have these packages all loaded up here. We also have a bunch of metadata in JSON files. If I click variables, we see variables that the model expects. These are all inputs, things like the age of the credit line or the number of credit lines. We also get outputs like EM classification, which is the classification that the model predicts whether or not they're going to default. The event probability, which is the underlying probability used to generate those classifications. And since I imputed missing variables in the pipeline, those are all outputs from the model as well, because they were created as part of creating the model. We have version control. Of course, I've only registered one version, but if we updated it, I could make a new version here. So before we publish this model, which is really what we want to do to deploy it, let's look at some of the options we have for managing it. So I'll click Projects here on the left, and I always open this so I can see the name. So I'll click Projects. And we see the project that I created it from, Model Management Example. I'll double click that. I'll click this once to open it. And now we see here's my gradient boosting model, but it doesn't have a role yet, so nothing's really happening here. So my very first step is to set my model as the champion model. So I'll click it. I'll click the snowman in the right, set as champion. When I set it as my champion, it asks me if the output that it creates, the event probability, which is ultimately the output that we want in order to make our predictions, it asks me if it's the same. It is the same. We'll see in a different model later on that it's not always the same. You'll see what that means. This menu is saying, do we want to add all of the input variables to the model to the project? I always click yes. It's basically saying all the metadata that the model expects should be metadata that the project expects as well. So now we have our champion model, and if I go over to variables, we see all these variables and then the output variable, which have all been added to the project from the model. We have some properties for the model, which I'm going to set real quick, or properties for the project. The target variable is bad. The target event value is 1. The target values are 1 and 0. The target level is binary. And the output event probability is that EM event probability that I'd mentioned before, which is pretty much a default for all SAS models. But we'll see when I bring in an R model that there's a different probability that it produces. I click Save to save the changes I made in the Properties page. So these are all changes to the project. Before I move on to do a test score or some performance reports, let's bring in an open source model. So I've got this model, and I want to show it to you before I import it real quick. So I've got this model. It's an R logistic regression, and I'm just going to open up a code file real quick in Notepad. So this is some R code that I actually have in a text file that I just wanted to show you. I execute this R code anywhere where R runs to build a machine learning model in R, and this is going to be a logistic regression. Rather than going into detail on how to build models in R, I just want to scroll down to the bottom to find the really important step. We're going to create a markup file with the predictive modeling markup language, PMML, using an R library, PMML, to save an XML file in the PMML format. So once you build your model in R or you build your model in Python, this will be the final step that you need in order to load it into Model Manager. You'll need to make this XML file. So this step right here, when I execute this in R, it will create an XML file that I'm going to consume shortly. I just should point out we've created some JSON files as well with a bunch of fit statistics. That is an optional step in order to give you more information about your model in Model Manager. So back to the software. I'm going to click Import. So we're in our Model Management Example project, and I'm going to import a new model into this project. I'm going to open a file. It expects an XML file. So I'll select this R logistic regression model XML file that was produced as output from my R code. When I click Import Model, it'll appear alongside the gradient boosting model as another model in my project. So when we're actually deploying a model, we can select the best between these two models at any given point. As part of that philosophy, I'll set this as the challenger model. So I select the R logistic regression model. I set it as a challenger. Here's where I was pointing out the EM event probability is the probability of classification for the BAD, binary applicant default variable. In R, the R model outputs predicted _ bad, which is the probability for predicting bad, binary applicant default. So I just need to tell the project that these are the same variable. Once I've done this, I now have my two models. And notice everything is version 1.0 because I haven't been doing any version control yet. We'll now do a score test to test that we can score our model. I'll click Scoring. I'll create a new test. I'll call this Example Test. And I can choose one of these two models. I'll choose the gradient boosting model. And under Data Sources, I'll bring in a new HMEQ data source. So I'll just go to Import. So this is we built our model on last year's data, and let's say this is data from Q1 of this year, and we want to test it to make sure that our model is working. Now, of course, since it might be new data, we might not have the scores. In this case, we do have the scores because all of it's from a couple years back. I'll click Save to save and run the test. I think of this test sort of serving two purposes. One, it tests that your model actually worked and that it can score. And it also tests to show you what the output is going to look like so that you can see how it works in Model Manager. So I'll click Run to run the test. Once the test is finished running, we can examine the results, which is just going to be the original input table that we gave it along with the predicted probabilities. So if I click Output, under the output, if I scroll all the way to the right, let me look for the variable actually. Not all the way to the right, about halfway to the right. We're looking for predicted, the probability of classification. The probability for bad equals 1 or the probability for classification. You can see they're basically the same numbers. So you use these numbers as your scores, and this is what you'll actually consume on the output. So we can see the score test did work, and we're able to score in Model Manager. This score test is really just a test, because when you deploy the model, you probably won't have to constantly use Model Manager to score new data. We'll see at the end, you can publish your model to score it externally. Before we publish our model to score externally, we want to have some way to evaluate our model over time. So I'll go to the Performance tab, and I'll create a new performance report. So I'll create a new definition here. The idea behind the performance report is our models expire after some period of time. We build our model from last year's data, but at some point during next year, our model is going to perform worse and worse. So we use these performance reports to evaluate our model on different data from different time periods to see how our model degrades or if it does degrade at all. So I'll use a library with a specified prefix. I'm going to load up all my data into the public library by default. So I'll click Cast Shared Default. I'll scroll down to the public library and select it. And the prefix for my data set is HMEQ. We'll be using HMEQ data from different quarters instead of the whole year data from the year before. Click OK. I do have to give it a name, so we'll have quarterly evaluation of model. And I've already specified the tables. And the models I'm going to use the current champion, so the reference model, the gradient boosting model. And I'm going to save this performance report. Now, I can't run the performance report until I load up the new data sets. So I'll be right back in heading to Manage Data, which is SAS Data Explorer. It's a slightly different interface. I'll just be loading up a couple data sets, and then I'll head back to Model Manager. So I'll go to Import, Local File, and I'll import all 5 of these HMEQ data sets with different prefixes. Import all. One of them gave me an error because I'd already imported it to do the scoring test. Excellent. We have all our data available now. If I go back, and by default, it imports it to the public library, which is why I specified that in Model Manager. So I'll go back to Manage Models. And now that I've saved the quarterly evaluation of models performance report, I can run it, and it'll look for those data sets that I put in the public library that start with the prefix HMEQ. So the first thing we can look at is how the variables change over time. So we see the debt to income ratio variable seems pretty uniformly binned across all the quarters. But if we look at the years on job variable, we see at the different quarters, which correspond to different HMEQ data sets that we loaded up from different time periods, we see that the variable distribution for years on job, YOJ, is very different. So this means that this variable looks very different in the different quarters, which suggests to us that perhaps the model isn't going to work as well if this variable is really important, because in the different quarters, it's a totally different variable. I can scroll down. The thing I usually like to look at in these performance report is lift and ROC. And we can see in the lift table, Q2 and Q5 have the best results. Q4, Q3, and Q1 don't do as well. So it does look like our model degrades, although it's a little bit out of order here. If we scroll down over here to the ROC chart, we see that Q1 has the very best performance on the ROC plot, which makes sense because it's most closely related to the data that we trained. And then Q3 and Q4 tend to do a little bit worse. Q3, Q4, and Q5 all do quite a bit worse than Q1 and Q2. This suggests to us that our model performance has degraded over time, and it might recommend to us to get a little bit more recent data and retrain our model on more recent data. We can also look at fit statistics like the Gini coefficient or the Kolmogorov-Smirnov statistic and see that the model performance is definitely degrading over time. When we evaluate on Q5, we do a lot worse than when we evaluate on Q1. Now, of course, for us to generate any of these statistics, we need to know the answers. We need to know the predictions for binary applicant default for Q1 through Q5. So this is just a way to evaluate your model over time after you've collected your data. Now, if we've identified that the model isn't going to do as well as we want, we can go ahead and retrain it. So if I click the actions in the top, I can click retrain, and I can retrain the model with a new data source. And I'll specify the data I want, the most recent HMEQ data. So if I refresh this page, I'll choose HMEQ 5Q5 because this is our most recent data. And let's retrain the model on the most recent data. I'll send this. So now we've sent a command for retraining the model. And if I look at the history page, we'll see that all of my actions here in Model Manager have been recorded. And I think this is a really big advantage of Model Manager, is that we can see when people created the model, when they set champions and challengers, when they created project versions. And we'll see I actually submitted that retraining for the software to retrain it on its own. And so that would appear as well. If we look at here. So now that our model's here in Model Manager, we've done some management on it to make sure that everything's working as we would like it and that our model performance hasn't degraded over much. We're ready to publish our model. So I'll click Models. I'll click the gradient boosting model. I'll select the actions here. Actions publish. It doesn't like the default name because it doesn't want any spaces in the publishing name. I'll select this. I'll publish it to Micro Analytic Services. Depending upon how your SAS VIA is configured, you'll have different locations here. So if you have SAS ESP, which is Event Stream Processing, you can also publish your models to be consumed by the Event Stream Processing engine. However, the Micro Analytic Service is the one that's by default configured with all SAS VIA environments. And it's basically just a smaller version of SAS that you can deploy on location. So if you have a database where your data lives, or if you have a dedicated server and you don't want to run SAS VIA on the server where you're storing your data, you can store your data there. So I'll publish to Micro Analytic Services. The model's been published successfully, and it's available here in Micro Analytic Services under Modules Gradient Boosting. And so if we had our data and anywhere accessible to this Micro Analytic Services module, we could then call this model and score our data on somewhere other than the SAS VIA environment where we're doing all of our model building. This can often be beneficial because you'll use a lot of resources for building models, especially complicated models like deep learning models, but it takes a lot fewer resources to score the models. And you often want to separate out model development and model deployment and scoring into separate environments so that, I could imagine customers asking for their data to be scored aren't waiting in line while you're training your model. So those are pretty much our model deployment steps. The one sort of part of the story that I haven't mentioned is that you can always deploy your models by just downloading the score code. So if I open up this gradient boosting model or the R logistic regression model, if we go to files, there is this score code in the analytics store file, and you could just right click and download these files straight from Model Manager and use them to score your model. Now, of course, when you pull the files out of Model Manager, you lose a lot of the governance and version control and management tools that we've provided for you. So there's sort of a right way to do things, which is publishing them to Micro Analytic Services and using it. But it's nice to have flexibility if you want to do other model deployment steps. And of course, we can do the same thing with the R logistic regression model. I may as well go into it. we have score code from SAS that was created when we loaded the model in. So we also have SAS score code for the R model, which I think is pretty unique. The final thing I may as well highlight, since we're here and it's showing up, since I asked for a retraining of the model, we now see version 2 for the gradient boosting model, because I retrained that model using newer data. So version 1 was trained on the HMEQ dataset, version 2 was trained on the HMEQ Q5 dataset, so the newest dataset that we have. Thanks for watching How to Deploy Models in SAS. Hopefully you've gained an appreciation for how the deployment process is perhaps a little more than just downloading the score code and emailing it to IT. Check out links and descriptions below. Feel free to ask comments and questions below as well, and be sure to subscribe. Thanks.